In this video, I'm going to talk about our van electrical and plumbing systems. I'll explain how we put the systems together and also all of the components that we use. So if you're building your own van, or even if you're hiring a builder to do it, just so you know the right questions to ask and the things to look for, then this video is definitely for you. So let's start with the electrical side. You can see here a lot of blue. We like to use Victron components. Victron's a great company. It's very popular in the marine industry, the RV, the van industry, and also off-grid applications. So we build an enclosure made out of extruded aluminum to hold both our electrical and our plumbing systems in. And then you can see we've got these covers on them, and we put doors in the cover so that it's easy to access everything. But you can notice that we don't put anything on top. So what we'll do is we'll put these extruded aluminum bars across, spanning the electrical and plumbing boxes, and we'll have 4 of these bars evenly spaced, and then we'll make a bed platform out of this same hex ply. And that'll be in 3 pieces. 1 piece over this electrical box, 1 in the middle, and 1 over the plumbing box. And those will sit on top, and then the mattress will be on top of that. So what it does is your platform will be up here. There will be a gap of 1.5 inches where you can get good airflow. On the electrical side, the inverter gets pretty hot. The other components get warm, but the inverter, when it's running, gets pretty hot. So we like to leave this top section open so there's really good ventilation. And then we also cut some slots for airflow in the covers so that we can get fresh air in, and then the heat can rise and come out the top. So we like to have really good ventilation in these. That's important. Your system will run a lot more efficiently when it's not overheated. Okay, so let's start with the batteries. So we've used a lot of different batteries in our day, and there's a lot of really good batteries out there. We do like to use batteries that are from reputable companies with good warranties. We've used Battleborn, SOK. We're now using Epic batteries in most of our builds. We really like the Epic batteries. Kind of hard to see here, but they have a 300 amp hour 12 volt battery, and that's what we have back here, 2 of those. So 2 of those at 300 amp hours is 600 amp hours total. Now in most of our systems, we do a 24 volt system, so we wire those 2 batteries together in series to create a 24 volt system. And make sure you stay till the end of the video, because I'll explain why we use 24 volt systems versus 12 or 48 volt. One thing I really like about these Epic batteries is that they are about the same footprint, not much bigger than just a 100 amp hour battery, but you're getting 300 amp hours. And they fit nicely even in a 144 in the back, and don't take up much room, and give you a really good amount of battery capacity. Then we take the batteries, and from the batteries, we run the positive lead up to a battery switch that we connect to the links distributor. This is a Victron links distributor, and that's just a really nice way to organize all of your distribution to the different components. Makes it really clean. All it really is just a couple of positive and negative bus bar with fused locations, so that everything can be fused. You could accomplish the same thing using separate fuses and breakers, but it just wouldn't be as clean and organized, and it would end up costing almost as much to buy all of those, if you were using breakers, to buy all the separate breakers and all the fittings and everything to do that. So we really like using the links distributor for that. We have a Link Smart Shunt. We use that going into the distributor. And so the negative lead is going to that smart shunt, and then into the distributor. The positive is going through the battery switch into this and into the distributor. The links distributor has 4 different fuse positions to connect things. You can actually hook up 2 or more of these links distributors together if you need more spots than that. But we typically just need the 4, and then we do 1 more for our air conditioner, and I'll explain to you in a minute how we connect that. So from this, we have the first position is our DC fuse block. So we have a positive and negative wire coming out of the links distributor and going to our 12 volt DC breaker panel. We like to use the Blue Sea breaker panels. They're really well-made breaker panels. There are other options out there that are less expensive. but this is the one we like to go with. And this DC breaker panel only has connections for the positive leads. So we do a negative bus bar right up here for all the negatives. So you can see we've connected all of the negatives from the different components to this negative bus bar. And then we've connected all of the positive leads to the positive side. Then we do connect one wire from the negative bus bar to a negative post on that DC breaker panel. Now the Blue Sea, they do make different variations of this breaker panel. They make one that is actual breakers that will trip and you can reset them. And then they also do them with fuses. You can do either one. We tend to just use the breaker panel one because it's easier, but they both work equally well. So the next position on this Lynx distributor goes to our solar charge controller. So we have our solar wires coming in from the roof, running them across here and in through a breaker and then into the solar charge controller. That's the voltage from the solar panels coming in, and then we have it going out to the Lynx distributor. So basically what this Lynx distributor is doing is taking all these different components and connecting them to the batteries. So rather than just trying to connect everything directly to the batteries, the Lynx distributor allows you to connect everything into the distributor, and then there's one connection that goes from the distributor into the batteries, and everything is fused for protection. So the next spot here is the Orion alternator charge controller. Victron has come out with a new charge controller called the Orion XS, which is a 50 amp charger, but that's only available in 12 volt at the time of this recording. Eventually they'll come out with a 24 volt version, which I'm really excited about. But for now, when we're doing a 24 volt system, what we do is we connect two of the Orions, two of those. So it's a 12 volts, both of these coming from the vehicle's alternator, and then converting that to 24 volts to go into the Lynx distributor. It's putting out 15 amps, taking 30 amps basically each one for a total of 60 from the alternator, and then taking that and converting it from 30 amps each down to 15 amps at 24 volts and sending that into the Lynx distributor.
Hey guys, do you enjoy the outdoors but planning meals has got you down? Whether it's space, weight, refrigeration, or prep, healthy, quick, and easy, delicious meals can be a real challenge. More and more people are turning to Thrive Life freeze-dried meals because they're lightweight, need no refrigeration, have no preservatives, and taste amazing. Just add hot water and you've got a meal in less than 10 minutes. With breakfast, lunch, and dinner options, Thrive has got you covered. Check out the link in description for more info.
And then the final position here is for my inverter. So the inverter is on the end, and it is the Multi-Plus inverter, the Victron Multi-Plus 24 volt version. And basically we've got the wire going from that, from the Lynx distributor into the inverter. And then we've got two connections, an AC in and an AC out on the inverter. The AC in is our shore power. So on the outside, on this wall of the van, we have a shore power inlet, and then we've run a wire through here and into the inverter so that we can plug the van in to shore power and charge through the inverter, charge our batteries. But then it's also got an AC out, and that AC out goes from the inverter to our AC breaker panel. Again, we like to use the Blue Sea. So this is a Blue Sea breaker panel, AC panel, and it comes with a 30 amp breaker, main breaker. So it's 30 amps coming in. This inverter is capable of putting out 50 amps. So you can either swap the main breaker out, change it from a 30 to a 50, or you can just program your inverter so that it only puts out 30 amps. And then you can use the breaker that comes in that breaker panel. Now, when you're running a 24 volt system, some of the components will work with either. So the solar charge controller will work with 12, 24, and most of them even 48 volt systems. And you just, when you go to program it, you set it to what your voltage of your batteries are. The Lynx distributor will work with any voltage, but the Orion alternator charge controllers and your inverter do need to be matched to your systems. So if you have a 24 volt system, you're gonna have 24 volt Orions, 12 to 24, because your vehicle's 12, but then the batteries are 24. And then also your inverter needs to be matched to your batteries. So if you have a 24 volt system, you're gonna have 24 volt inverter. Okay, now with a 24 volt system, actually most of the components in your van are gonna be run still at 12 volts. So you need to convert the power down. So what we do is we go from the Lynx distributor, that DC out, and we run it through an Orion converter. This is a Victron Orion converter, which takes your 24 volt, converts it back down to 12, and then there's an output from that at 12 volts that goes, we run it through a little bus bar, and then to the DC fuse panel. So the DC fuse or breaker panel is 12 volts because all of the standard devices you buy for a van, the lights, the water pump, all of those kinds of things are probably going to be 12 volt. Some of them are available in 24, but it's just easier to run those at 12 volt. There's not a huge benefit in those in running them at 24, so we convert that down and to 12 volt and run all the devices on 12 volt. The only thing that we run at 24 volt is the air conditioner. So in this van and all of our vans, we typically put the Nomadic air conditioner by Nomadic Cooling. So either the X2 in a 144 or in larger vans, we'll usually upgrade to the X3. So the way that we connect the air conditioner to this system, and I do get a lot of questions on that. So here is a Lynx distributor. I've taken the cover off and you can see the 4 positions. The fuses would go across these and where you can connect those different components. So on this end is where your power, your positive from your batteries comes in and your negatives. On this end, there are a couple of extra lugs. And like I said, you can connect a second Lynx distributor to this. We normally don't do that because we don't need those extra spots, but what we do is we use these last lugs to connect our air conditioner, so the positive and the negative. Now, anytime you're connecting DC devices, you need to have a circuit breaker or a fuse. So the couple of different ways you can go is you can put a terminal fuse right here on this positive lug and then connect your air conditioner wire to that, and then your negative to this one. Or the other thing you can do is, what we do is we just run a short wire off of this positive lug and run it to this breaker. This is a Blue Sea breaker, and this is a 50 amp for a 24 volt air conditioner. And so we just run a short wire and connect that, and then connect the other side of this wire to this, and then run it up to the air conditioner. So that's how you can attach an air conditioner without needing to buy an entire additional Lynx distributor. Now hopefully you can see on this Lynx distributor there's a little light here. It's got additional LED lights so that if a fuse blows, it'll light up and you'll be able to see it. The problem is that those lights don't work unless you're either using a Lynx shunt or a Lynx smart BMS coming into this. And typically you don't need that unless you're using the Victron batteries. So with just the Lynx smart shunt, these lights aren't going to work. So what we do is make up a little, what we call a jumper wire, which will plug into this little phone jack and then connect to the positive and negative here. And that will enable these lights so that they'll work. It'll provide power. This actually requires 5 volts of power. So we have a little converter on this jumper wire where it will connect, where it'll take the 12 volt power from this, convert it down to 5 volts, go into this jack, and then the lights will work. So it's a nice thing. If you're gonna spend the money on this setup, it's really nice to have the lights working. And so we've done a whole video on how to enable those lights with that jumper wire. So you can do it yourself, or if you'd like to just buy the jumper wire, we do have that available on our website. And you can click a link in the description, or I'll put a link right up here where you can order that. Now, one thing I just want to mention while I'm talking about this, this is what we call our wire trough. And it's really nice. We just make this little piece where we can run all of our wires across the bed. So if you're doing a fixed bed, it's a really nice way to do it. If you need access to these wires, all you'll have to do is just pull the bed platform up and you can get at these. We put an outlet right here so that we'll have a bench over here and you can just plug into that for an extra outlet. You can also use these troughs for passing plumbing across. If you have a shower on one side and a sink on the other and you need to send your plumbing lines across, that's a nice way to do it. This makes your wires really accessible, allows you to run additional wires in the future if you need to, and avoid having to go all the way up and through the ceiling and back down the other side to run your wires from one side of the van to the other. Over on this side, we have our plumbing system. Really, it doesn't matter what side you put things on, really what's most convenient. In this van, our galley is on the driver's side, so that's why we put our plumbing on the driver's side. If your water is going to be on the passenger side, then you could certainly put it on either side. If you are doing a split water system where maybe you have a shower on one side and a sink on the other, then you are going to have to run your plumbing lines across the van, and the trough is a good way to do that. Now, I just want to mention I'm talking about a lot of different components in this video. We've spent years researching and testing the products that we use in our vans. These are products that we highly recommend, that we use in all of our builds. And I started as a DIY builder, and I like to support the DIY van building community. So we've developed a Google Sheet with all of the components that we use in our builds, with all links to everything. And I'll drop a link to that Google Sheet down in the description. And also you can click right up here if you'd like to access that sheet. And another resource that we have for DIY builders is what we call our van build sequence spreadsheet. And it just goes through the sequence of the build the way that we do it. It's not necessarily the only way to build a van, but it's the process that we've kind of refined over the years and find works best for us. Because a lot of times if you do things out of order, you get towards the end of the van and you find you either can't access something, or you've got to tear something out to get at something else, or maybe things don't just match up just right, and then you end up not having a really clean finished look. So if you'd like to check out that van sequence spreadsheet, then there's a link down below. So on to the plumbing system. Let's start with the tanks. So we really like the over-the-wheel well tanks. We get these from Northwest Conversions, and there's a lot of places out there that have the over-the-wheel well tanks. There's a couple of reasons why I really prefer these tanks. One is that the low center of gravity, they can sit down on the floor of the van, because there's a lot of weight. This is a 36-gallon tank. I think that's about 250 pounds or so when it's full. And you get that much weight if it's up above your wheel well sloshing around. It's kind of a awkward high center of gravity. The other thing I really like about the over the wheel well tanks is that the part that is molded for the wheel well acts as kind of a baffle to help the water not slosh around as much. And so that helps as well with the balance in the weight distribution. And we typically use the 36-gallon tank. Sometimes we'll use a 24-gallon tank if a customer wants it a little bit narrower, wants a little bit wider garage, but we find that the 36 is kind of our go-to. Then what we do is we have the water line coming from the tank into a water pump. And this water pump we really like because it does not require an accumulator. An accumulator is a kind of a pressurized tank that goes next to this that helps the pump not to cycle as often. Well, this pump doesn't need that. You can add one, it doesn't hurt, but I find that it doesn't really help either. And so it allows you to just eliminate that extra piece. This water pump works great, and we put it in a lot of vans, never had any problems with it. So from the water pump, we then go to this manifold. And this manifold is a 3-port manifold. We have one line that's going to go up to the sink, one line that's going to go to the water heater, and one line that's going to go to the outdoor shower. And this is the cold side. And you can see that we put shutoff valves on everything. And the reason for that is if, for example, your water heater stopped working or it sprung a leak, you could shut that off and be able to use the rest of the water and not have to worry about that leak until you get to some place that you can get it fixed. The other thing you can do is you can see all of these braided lines. We really like to use these lines because you can unscrew them easily. If you need to replace your water pump or your water heater, all you've got to do is disconnect these lines, take the part out, put it back in, reconnect the line. So it makes it really simple and easy to connect everything. We also found when we were using the clear braided hose with hose clamps on them. If we ever had any leaks in the plumbing system, that's where we had the leaks. Never have had leaks in these PEX fittings, but we had leaks in the clear hose. And so using these braided hoses that thread on, we've never had an issue with any of these. Okay, so this line, like I said, goes to our water heater. We really like to use the IsoTemp water heater, and we also do a lot of builds with hydronic systems, and we've got a whole video comparing the IsoTemp water heater system to the hydronic system. But kind of our standard build is the IsoTemp electric water heater. We use the 15-liter, which is about 4-gallon water heater, and it's electric water heater, and it's pretty efficient and it's pretty well insulated. So once you heat up the water, it will stay warm for, I found, pretty much overnight. It'll stay pretty hot, and even 24 hours later, it's still pretty warm. One little pro tip I always give everyone is, if you can, run your water heater while you're driving, and that way your alternator is going to be doing most of the heavy lifting of heating up the water. Then if it's already warm, you just need to heat it up a little, and that way you don't need to use your van's battery power in your inverter. The cold line goes into the bottom of the water heater, and there's the hot line that comes out, and we split that off, and one line is going to the outdoor shower and one's going to the sink. If you had an indoor shower, you can run another line to that. Now here I am at the back of the plumbing box, and you can see the fittings here. We really like to use these Aquar fittings. There's one for the, it's called the RV fill inlet, for filling the freshwater tank. And then there's one for the shower right here. And one thing I really like about these is they just use these little quick connect fittings. There's one for the shower, and so you just put it in, half turn, and that's how you connect that. And you disconnect it, and there's a check valve in here that keeps any water from coming out. And then there's another one that's a little bit different, has a bend in it and has a shutoff valve for the fill. But you just connect it there, turn the valve on and off to fill the tank. And then this is just the shower mixer. And Aquar has actually just come out with their own shower mixer, so we're now using that one. But this one works great. This is by Ambassador Marine. And then there's also one from Aquar that we like. And so you basically would just connect your shower line to this with a handheld shower hose and run your shower hot and cold water right from there. Now, one important thing is, when you're filling your fresh water tank, you want to make sure you don't overfill it. So you want to make sure you have a way to see it. So we do this little door right here where we can store our hoses and stuff in here, but you can also see the water tank as it's filling so that you don't overfill it. Now we do an overflow, so if you do overfill it, it just spills out underneath the van, but it's better just to not overfill it. So you want to be able to get your eyes on the tank and be able to watch it as you fill, make sure you don't overfill it. So another thing that's really important in a van or RV is access to everything. Because components eventually are going to fail. Water pumps, water heaters. On the electrical side, we've had an Orion go out. We've had a solar charge controller go out. You could even have your inverter go out, or even have to replace your batteries. Most of them have a 10-year warranty, but eventually you may have to replace those. So access is really important. So with our mechanical boxes, the entire top, like I said, is open, so you can get out from the top. But if you don't want to have to remove the bed, we put these nice big door hatches so that you have access to all the important components right through the front on both the plumbing and electrical side. We also these are all just panels, so you can unscrew these panels and take the whole thing off if you needed to get at something as well. It's really important when you're designing your mechanical boxes, plumbing and electrical, that you leave yourself access, make sure you can get at things when you need to. So right here you can see our panels. So this is the DC breaker panel like I was talking about earlier, and this is the AC. Like I said, we like the Blue Sea. I think they're just really clean and they're really high quality. There are some other options out there, which we have links in our spreadsheet to some less expensive options. Like this one I think is about $150, and this AC panel is about $200. There are some panels that you can get for probably half of that price, that are common in RVs. There's nothing wrong with those. When you have it exposed, I just like something that is a nice looking panel. And then also we like to put an outlet off the back. So if you need any type of AC power off the back, you've got it right here. So there's an overview of our electrical and plumbing systems. And this is how we do all of our systems on all the vans we build. We also build both of these systems as drop-in systems. So if you're building your own van, but you don't want to do the electrical and the plumbing, we can build this for you. We can do either just our standard setup, or if you want it customized, if you don't want it this high, or you're doing a bed that sleeps north to south and you want it a little bit longer, we can configure it however you need it. And I'll put a link down in the description below where you can check that out on our website. Now, I promised if you stayed till the end, I'd explain to you why we do 24-volt systems versus 12 or 48. I get the question a lot, why aren't you doing a 48-volt system? 48's the future. Well, I agree with that. However, right now in the van world, I just feel like 48-volt isn't quite as well supported as 24. There aren't as many options for the alternator charging and even the battery. So in order to create a 48-volt system, you either need a 48-volt battery, or you need two 24-volt batteries that you can wire in series to create a 48-volt battery, or you need four 12-volt batteries that you can wire in series to create a 48. I don't like the option of the 4 batteries because it just takes up a lot of space. I do like the option of 2 batteries, but there aren't very many 24-volt batteries. There's not a very big selection of them out there, and they're quite a bit more expensive than the 12-volt batteries. So we find that, especially with these epic 300 amp hour batteries, 2 of those wired in series together creates a 24-volt system. Very small footprint, lots of battery capacity, plenty of capacity for most people in a van. And so that's the main reason we're not doing 48-volt right now. As more battery options become available and more components, maybe the alternator charging for a 48-volt system becomes more readily available, and as more battery options become available in the 24 or even 48-volt world, then we'll probably move to that. But for now, we're pretty happy with the 24-volt systems. So what are the advantages of a 24-volt system over a 12-volt system? Well, you do get a little bit of efficiency. What happens is when you double the voltage from 12 to 24, you cut in half the amperage. So for example, if you have an air conditioner that runs at 100 amps at 12 volts, if you were to get the same air conditioner in a 24-volt version, it's going to run at half the amperage. So instead of 100 amps, it's going to run at 50 amps. Well, that current flowing through your wires creates heat, and more heat creates less efficiency. So 24-volt systems can be a little bit more efficient because they create a little bit less heat. So really for me, the biggest benefit to using the 24-volt is being able to use smaller cable, especially for the batteries. So if you're running a 3,000 watt inverter, say with 600 amp hours of batteries, you're gonna need to probably run 4-aught wire, which is right here. So you can kind of see the size of that 4-aught, but if you're running the same size inverter, same size battery bank, then you're likely able to use a 1-aught. Now I recommend looking up for your system exactly what size cable to use. There would be the difference between a 4-aught and a 1-aught cable. So with the 4-aught in such a small area, it can be really hard to route these wires and get them where you need them. Where with the 1-aught, they're a lot more flexible, a lot easier to work with, less expensive, and also crimping on the lugs is a lot easier with smaller lugs, smaller crimps, all that kind of stuff. So I find that especially on the battery cable, it's just a lot easier to work with a 1-aught. So that is really my favorite part about working with 24-volt. Now obviously you went to 48-volt, you could even use smaller cable. So hopefully this video helped. If you'd like to see more videos about van building, van life, components, tools, products, please consider subscribing and be sure to smash that like button. And we'll see you in the next video. Jeff with Thrive Vans, thrive on. See ya.